right now we want to create a project for the application tree on the Zedboard, which is the CB2CED hardware control. Again, you don't need to add anything. Just go for boards, get the Zedboard. I'm using revision D, by the way. Finish. In here, go for your project settings. Once again, get IP. Could you add the IP repo where you save the other two design sources for the IP block? So in here I actually use the same folder for both of them. So I'm gonna apply this, hit OK. I'm gonna create a block design right now. I'm gonna call this one CB2CED hardware control. Maybe I'll put a Z on the top. So just in here we want to add a zinc processing system, and we also want to add our CB2CED hardware control. So you can run block automation for the processing system, and you can run the connection automation. So in here what we have is inputs and outputs that have to be declared for our custom IP. So right click here, make external, same one for up, and do the same for the outputs. So right now what we need to do is tell Vivado where these inputs and outputs are located on the board, and in order to do so we go for sources. We're gonna add saucer here. It's a constraint file. I'm gonna call this one, I'm gonna create one actually called hardware underline control. So finish. And once this is done, we should see a file here. It's empty. So we want to go to the internet and actually download the Zedboard masters constraint file. So if you Google ZXDC master, you see a link for Zedboard documentation, and you go down a little bit here and you should see Zedboard masters XDC for revision C and D, released in 15th of April 2015. That's the most recent version of it. So you should just download this. I've downloaded this already, and if you extract, you see it contains a file here which grants you a lot of power for Zedboard. So in here we actually have some notes, we have some explanations, and then you got some pin planning here to be done. So we're just gonna look for the LEDs. We need the LED 0 and 1 and 3 and 2 actually. So we're just gonna copy those. I'm gonna paste here, and LED 0 will be actually turned into count 0. The LED 1 will turn into count 1, and the LED 2 will turn into ship enable outputs. Those are all our outputs right now. So let's look right now for a push button. I'm gonna use the left one, basically because it's closer. So just copy this, paste here. Instead of button left, it will be our SW. I know we call switch, but it's actually easier to use if it is a button. So let's leave a space between every line here, because we're gonna still have to add some code on it. And we go back here and you look for a switch now, dip switch. Here, user dip switch. So take the switch 0, copy this, go back to Vivado, paste this here. So in here what we're going to do is set underscore property what we're going to put here is this piece of code, IO standard LVCMOS 333, and you want to put the variable on the top as well. So the reason why we're doing this is to tell the Vivado that the default voltage level for this pin is 3.3 volts. So here we're gonna CO, here will be switch, and on switch 0 we actually haven't put anything yet, but it's actually the up down selector. So just go up here, save your constraints file. This is wrong, see, get this inside the brackets. So right now, if we don't have any errors, just save these SDK, and yeah, maybe put some semicolons here on the end. Now save your XDC file. Right click here, block design, create HDL wrapper, let Vivado manage and auto update. So we wanna generate our bit string, save. If we have some sort of error, actually I'll be waiting until the synthesis is completed, because I'm not sure if we should have the semicolon. I think it doesn't really matter if we have or if we don't, but in such case just gonna wait, and if our error pop up I'll just let you know. So I don't have any error on the synthesis, and I'm about to finish the run implementation design right now, and I don't think anything will actually pop up. Yeah, it won't. So right now I'm running the bit string. That's the last step to generate your bit string file, and then I'm gonna export the hardware and go for the SDK to run the application on the board. So our bit string generation is completed right now, so hit OK, wait for open the implemented design. Then what we would do is export the hardware with the bit string and launch the SDK. Once we launch the SDK, we actually won't be needed to writing any C code at all. So just try to make this video a little bit longer in order to be just this one piece. So in here, what we need to do is create an application project. Just call CB2CD hardware control. You need to put that on the front. Make sure that you're creating a board support package as well. Get the Hello World template. Hit finish. Once this is done, you want to program your FPGA. Then you're gonna right click here, run as, and launch on hardware. I'm gonna try this again. Binary, not phone. Okay. Go for terminal, see connections, hit serial. Yeah, he's not recognizing the board for some reasons. Just restart the SDK in this case. So if you restart your SDK, just try to run again. Make sure you program the board before running as well. And then we shouldn't see anything right now. For some reason I'm not using the UART connection here, so it's not being recognized here. So there's no way we're gonna see anything on the console, but that's okay, because this is not the goal for this particular project. I'll do some video. So right now I'm gonna do a video with the results on the board, and I'll upload for you right away.